Let's catch up. While you're writing, we use sum and difference to help us solve sine, cosine, or tangent for angles that don't appear to be on the unit circle. But we can actually make out of angles that are on the unit circle by adding or subtracting values. Okay? Notice that if we take, let's look at these individuals, sine. If we take sine of alpha plus beta, that's angle alpha plus angle beta. That is the same as sine alpha cosine beta plus cosine alpha sine beta. That means if we had an angle like 75 degrees, 75 degrees is not on the unit circle, but guess what is? What two angles on the unit circle could you add up to get 75 degrees?
45 and 30.
45 and 30. So in this case, sine would be, alpha would be 45 degrees and beta would be 30 degrees. And all we have to do is literally plug in the other side of the formula, pull those angles off of, those values off the unit circle. Okay? Same thing goes with sine of alpha minus beta. Sine alpha cosine beta minus cosine alpha sine beta. Then we have the ones for cosine instead. Cosine cosine minus sine sine, or cosine cosine plus sine sine. And finally we have them for tangent. Tangent of alpha plus beta is tangent alpha plus beta, tangent beta, 1 minus tangent alpha tangent beta. Or subtracting, it just changed to a minus sign on top. Okay? Everybody good with that? Okay, we'll come back to double angle identities in a minute. So here we go. Find the exact value of each trig expression. So the first thing you have to do is figure out 15 degrees. Do I add or subtract to get 15 degrees? Subtract. So I want to write that as the subtraction of two different angles to get 15. There are lots of different combos, guys. They'll all give you the exact same answer. I usually try to stick to ones in the first quadrant if I can, because then I know they're all positive. Okay. 60 minus 45, you might have been thinking of 45 minus 30. Either way, both of them work. So what does our formula say for this is our alpha and this is our beta? Alpha is the Jesus fish. Beta is just like a curly bee. Look. Sine of alpha minus beta.
Oh, I thought it was just an A for real.
Is sine alpha, you can use A and B if you want. I don't care.
Oh, I am. So cute. Look at it.
Sine alpha cosine beta minus cosine alpha sine beta. Now let's fill in the amounts for alpha and beta into our formula.
Wait, yeah, I want to use 60.
Cosine minus now catch up, and then we'll go to our unit circle to finish this. These are even easier than the others, honestly. Once you get it written out, it's just looking on your unit circle. So what is the sine of 60 degrees? So this becomes root 3 over 2 times the cosine of 45 minus the cosine of 60, which is, and sine of 45. Okay, so root 3 times root 2 is, yep. So this becomes root 6 over 4 minus root 2 over 4, which we can rewrite since they have a common denominator, root 6 minus root 2 all over 4. That would be our answer. Guys, these are easy. You're given the formulas. Just write out the formula, figure out what alpha and beta are, and plug in. Now, tangent 7 pi over 12. These are hard to do in radians, so I highly suggest the first thing you do is switch them from radians to degrees. So let's do that. 7 pi over 12, what do we multiply by to get it into degrees? 180 over pi.
For you, these things could have used.
Yes. Yes. I don't expect you to memorize all of these. I know. So how many degrees is this? Okay. So what we're really looking for is the tangent of 105 degrees. So what two things add up to 105 degrees? No. Well, 60 and 45 work, don't they?
Yeah.
15's not on your unit circle is the problem. Got to be on your unit circle.
You said they have to add?
No, you could subtract if you wanted to, but the angle measures that are on your unit circle: 0, 30, 45, 60, 90. You could do it as a subtraction if you wanted to. 135 minus 30.
Oh, yeah.
It doesn't matter. The answer will work out either way. So let's do, I'm going to do addition because we haven't done an addition one yet. So this is alpha, and this is beta, right?
Yes.
So tangent of alpha plus beta is what?
Is tangent A is tangent B over 1 minus
Okay, so let's fill in. This becomes tangent what? Tangent 60 plus over 1 minus tan 60 times tan 45. All right. So what is the tangent of 60 degrees? Root 3. Plus tangent of 45. 1 minus tangent of 60 is root 3. And tangent 45 is 1. So this is root 3 plus 1 over 1 minus root 3. The only thing that's bad here is that you have a, well, you've got a radical in the denominator. Kind of sucks for you, doesn't it? So we got to multiply by 1 plus root 3. 1 plus root 3. Remember, if you have 1 minus root 3, you have to multiply by its conjugate. Now, root 3 times 1, root 3. Root 3 times root 3. 1 times 1. 1 times root 3. Yeah. 1 times 1 is 1. Plus root 3 minus root 3 goes away, doesn't it? And then minus root 3 times root 3. So we finish this out. We get root 3 plus root 3 is 2 root 3. 3 plus 1 is divided by negative 2. So now, everything can have a 2 come out of it, can it? A negative 2? So negative root 3 minus 2 is our final answer. Quit whining. Now I want you to try cosine of 15 on your own.
Close one.
I know wine inside for real.
That's because it's
Well, I have broken that many times.
You didn't have to agree.
You didn't have to agree. Oh my god.
Which one are we doing?
Wow.
I know I said it, but why did you say it?
Of course not. Which one?
I believe you're violating the sign right now. All right, try cosine of 15.
Choice.
So the first thing you decide if you're be adding or subtracting.
Do we get to pick either one?
Well, not for 15. What adds up to 15 off the unit circle? Nothing. So it's going to have to be subtraction for this.
Oh, right. Okay, I mean I got it right, but then I
Okay.
combined.
I got that.
You can't combine.
You
got that
can't. You
answer.
can't add
All
root
right.
6 plus root 2.
Nope.
Shut up. Like, who is that?
You can't get root 8.
Then I was right.
Oh my gosh, I need to
I just
figure out the
went
way
away.
I did it with the.
It should still end up with the same answer even if you pick two other amounts. All right, is everybody good with this? Anybody have any questions? Okay, so we're going to skip the next one and move on to what happens if it's already written out? You just recombine it. Look at this guy, E. Doesn't that look like one of the formulas already written out? Yes. So which one is cosine, cosine plus sine, sine? Alpha minus beta. Okay. So guess what? We just need to find alpha and beta and put them back together, don't we? Well, the first one's alpha and the second one is beta. So we rewrite this as cosine of now we need a common. What's the common denominator for 8 and 24? 24. So I need to multiply by what? 3 over 3 here. Now, This becomes the cosine of what? Minus all over. Now let's reduce. This becomes the cosine of what? Which will reduce to something on the unit circle. What goes into both 16 and 24? 8. So this ends up as what? Which is on the unit circle. What is the cosine of 2 pi over 3?
That's a hard question.
Where's my unit circle?
I get 1/2.
Yep. And that's the answer. So if it's already written out, we can recombine, put it back together. Sometimes it's easier to split it apart. Sometimes it's easier to put it back together. Okay? Now, if you are not good with fractions, change them both into degrees. Put them back together, and then when you get down to the 5, then you just work it out. We could have worked this out as degrees, couldn't we?
Yes.
7 pi over 8, 5 pi over 24. You could change them both, put them back together, subtracted them. It would have been really easy. You would have still found the answer on your unit circle. Try this one on your own. Y'all make me smile every day.
Oh, that's so sweet.
Insert the point.
Yep.
Oh, that's so good. We've only broke a fish.
I don't know why.
It doesn't even look like a fish.
You basically do 10, 32 plus 13, 25. And 10 and 25.
Right. We just all learned together. But what about the bottom?
It doesn't matter. The whole thing is in the, that whole thing is the formula. Look at tan alpha plus beta. It has.
Oh, it's just 10a plus b. I thought we had to.
Nope.
I got that too.
Now, try G.
I knew this was simplify. 6x.
Yep. You will not be using your unit circle for this one.
So almost like a meow.
Keep going. Put it back together like it needs to be. What's alpha and what's beta here? 6x. And so this is going to be tan what? Okay. So which is what? Oh, what's tangent of negative x? Good job, Bryant. And that's it. All right. How do we do these? Whoop.
Right, it's a trick question.
No, we do. We're going to combine something. This whole thing is alpha, and this whole thing is beta. So we are doing cosine alpha plus beta. So what is the formula for cosine alpha plus beta?
Cosine alpha times cosine minus
Find beta, right? All right. So now we need to write this out. We are going to do the cosine of, and we said alpha was arc sine 2x. And then cosine of beta, which is arc cosine x, minus sine arc sine sine arc cosine.
Wait, right, because I'm writing all of it.
Yes. Now, some of this gonna be easy, some of this is not gonna be easy. Cosine arc cosine and sine arc sine is easy, isn't it? Because doesn't cosine arc cosine go away and just the x is left? And sine arc sine goes away and just the 2x is left? So this becomes x cosine arc sine minus 2x sine arc cosine x. Now, this is where the fun starts. We don't know what arc sine is, but we do know it's alpha, right? It's an angle, isn't it? When you take the arc sine of something, the angle comes out. We've done these before. We need to create, this is like saying sine 2x over 1, isn't it? So we create a triangle here. This is alpha. Sine is opposite over hypotenuse, correct? Pythagorean theorem, if you remember, the Pythagorean theorem says side squared plus side squared equals hypotenuse squared, doesn't it? So if we have the hypotenuse in one of the sides, we can simply take the square root of the hypotenuse squared, 1 squared is 1, minus the side squared. So what is 2x squared? 2 squared is? And then that comes from the Pythagorean theorem. Now, why is that important? Because we want to find the cosine of this triangle. What is the cosine of that triangle? Adjacent, which is this, over, yes, minus 2x times, now guess what? We've got to use a different triangle for that guy. This is like x over 1, isn't it? So this is beta, isn't it? So beta goes here. Cosine is what? So this is x, this is 1. So again, this becomes the square root of 1 squared, which is 1, minus the side squared. So what's the side squared? Okay. Now we need to find the sine of this guy. Opposite over, so this is x root 1 minus 4x squared minus 2x root 1 minus x squared. And that's the answer, guys. It's the hardest thing we've done today. Yeah, probably. Maybe like a bonus. All right, so let's get to solving. Solving, we just used the formula. We've got cosine of alpha plus beta and cosine of alpha minus beta. So write small, because these are both going to get their own expression, aren't they? This is alpha and beta in both of them. Cosine of alpha plus beta is going to be what? Cosine alpha, cosine beta, minus alpha sine beta. And this guy's going to be cosine alpha, cosine beta, plus sine alpha, sine beta. This is all equal to 1/2. Now I want you to notice something. My alpha and beta are the same, aren't they? If my alpha and beta are exactly the same, guess what? Minus sine alpha sine beta and plus sine alpha sine beta are going to what? They're going to go away, aren't they? So that goes away. And cosine alpha, cosine beta, they're both the same, aren't they? So we add them together and we get what? Now let's fill in what those are. 2 cosine, what's alpha? And what's beta? What is the cosine of pi over 3? What's 2 times 1/2 here, guys? Doesn't that just go away? So what is the cosine of 1/2? Where is cosine 1/2? And this is on an interval, so we just need to figure it out. We have solved that problem. Let's do the last one, and then we'll move on to double angle, which is really easy too. Again, we just need to write these out, don't we? Check to see if your alpha and beta are the same. If your alpha and beta are the same, they become really easy. What is cosine alpha plus beta? Right? Now be careful with that minus sign because you got to put everything in parentheses here because otherwise you're going to have to distribute that minus sign in. Now this one's not going to be as easy because sine alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta, isn't it? None of these match, so we just got to plug in. So alpha is x and beta is what? So this becomes cosine x cosine pi minus sine x sine pi. Ooh, this is going to be nice. Minus sine x cosine pi plus, because remember this gets distributed, doesn't it? Cosine x sine pi. Does anybody see? Finish writing this down and then look at it. Does anybody see anything that can make stuff go away? What will help some stuff go away? Well, what's cosine pi? -1. So this becomes -1. So this is negative cosine x. All right, let's look at the next one. What's sine pi? 0. So this becomes 0, which means this whole thing goes away, doesn't it? Whoop, that's nice. Minus sine x cosine pi. What did we say about cosine pi? So negative times the negative makes this a plus sine x. And what does sine pi equal? So this whole thing goes away. So now we have minus cosine x plus sine x. I'm going to actually teach you a shortcut to do this one. We don't have to square. On this one, we can actually just move one of them to the other side. Which one you want to move to the other side? Cosine? How about cosine? So we end up with what? Now if we divide both sides, let's divide both sides by cosine. Anybody want to guess why I'm doing that? Ah, so tan x equals what? And that's on the unit circle, isn't it? Where does tangent equal 1?
5/4.
And 5 pi over 4, right? Those are 180 degrees apart, aren't they? There is no interval here, is there?
No.
Uh-oh. No interval means that we have to pi in, and we don't even need that one because they're 180 apart. Okay?
Oh no, my wrist hurts now.
Last but not least, go back and look at those double angle identities. We're going to be doing the double angle identities here. There are formulas for them. Sine, there's one formula for sine. Sine of 2 times the angle is equal to 2 sine angle cosine angle, right? Theta. Tangent has one formula, and cosine has 3 different formulas you could possibly use. There's 2 steps to doing these, guys. 2 steps. First step is you got to figure out what quadrant you're in. This guy right here is going to tell me what quadrant am I in if I'm between pi and 3 pi over 2.
Third.
So I'm in quadrant 3, which means that sine is negative, cosine is negative, and tangent is, remember that because those are in the formulas. The next step is I have to draw the triangle out. Here's theta. Sine is opposite over hypotenuse. Using the Pythagorean theorem, just to be fast, we could find that missing side, couldn't we? It turns out that missing side is 24. All right? 25 squared minus 7 squared is 576. Square root of 576 is 24. So now, sine of 2 theta is 2 sine theta cosine theta. Now we just plug in. Using this formula, this triangle, we literally just plug in. Sine is what in the third quadrant?
Negative.
So it's negative, and now use your triangle. What is sine? 7 over cosine in the third quadrant is, and using your triangle, what's cosine? Now just multiply straight across. Negative times negative is a positive. Positive 14 times 24, I believe, is 336. So this becomes 336 over 625. Let's do cosine. Okay. Cosine, I'm going to use the first formula. It is cosine squared minus sine squared. Okay? We can use the exact same triangle we just drew. So cosine is going to be what? Negative 24 over 25. We're going to square that, and then we're going to take sine, which was negative 7 over 25, correct? So that is 576 over 625 minus 49 over
Math is for me. I mean, I need this.
Okay, let's finish up with tangent. Tangent of 2 theta. Guys, are you getting the idea that you just plug in the formula?
Wait, is that a... Okay, that's a 2.
What is tangent of theta from that triangle? Opposite over adjacent, right? So it is 7 over 24. 1 minus 7 over 24 squared. So this is 14 over 24 divided by 1 minus 49 over 476. Right? Now, here's the cool thing. If I multiply everything through by 476, I can get rid of that compound fraction, can't I? Think about it, guys. 476 times 476 times 476. That goes away. And the reason I can do that is I know that 24 goes into 476 24 times, doesn't it? So now my fraction is down to 14 times 24, which I think we found was 336, over 476 minus 49.
We can't get this right.
Okay? There is one little section I am going to have to record and post, and that will be those last little using these double angles to solve. They won't be bad.
Wait, is that
Go
the
back and look
answer?
at it. Whatever 476 minus 49 is, 4 427, and then reduce if you can. Okay? Guys, just to reiterate, you look for this piece of it as you're leaving. You look for that piece of it to tell which quadrant you're in. The quadrant assigns the signs for sine and cosine and tangent of theta. You use this. So this is our quadrant. This is to help us construct our triangle, isn't it? And then use the formulas to find all these. Okay? Okay, so to solve equations, what you need to do is you need to figure out what to plug in. Well, this is the one right here, sine 2 theta. We know that's equal to 2 sine theta cosine theta. So this became this, all right? So now we can look at it and see that they both contain sine. So we're going to pull that out, factor it out. And we know how to solve this guy. So sine equal to 0. Set 2 cosine minus 1 equal to 0. Sine, and we've got an interval, so that's nice. So sine is 0 at 0, pi, and 2 pi. This becomes cosine equals 1/2. And cosine is 1/2 at, what, pi over 3. and 5 pi over 3. So there's our answers. All right? It's on the corner of your desk, my desk, right there. Purple.
Oh.
Remember, you gotta fill out your unit circle first and then use it for your test. Mm-hmm. Bye, Desiree. All right. So now for cosine, you have a couple different options. But since this is sine squared here, I'm going to pick the one that has sine squared in it. So this one is the third option, is 1 minus 2 sine squared. Okay. So I'm going to bring this over. And I get 1 equals, that goes away, sine squared alpha. All right, so now I have to take the square root. So I get sine equals plus or minus 1. So sine is positive 1 at pi over 2 and negative 1 at 3 pi over 2. And those were my answers. So you get the idea. Tangent of 2 beta. Tangent of 2 beta, if you remember, we're going to plug in for this, and that is going to become 2 tan over 1 minus tan squared beta equals 2 tan beta. Okay? So, now we've got to do some fun stuff. I'm going to cross multiply this over to this. So we get 2 tan beta equals 2 tan beta times 1 minus tan squared beta. All right, guys. I know you're going to be tempted to try to divide, but you can't. Remember, you've got to distribute this in. So 2 tan beta equals 2 tan beta minus 2 tan beta tan squared beta. All right? So now I can move this over. And look what happens. Canceled out on both sides. And that's tan cubed beta, isn't it? So divide both sides by negative 2. Still 0. Then take the cube root this time. Cube root is 0, 0. So we have tan beta equals 0. Where does tangent equal 0? Tangent equals 0 at 0 and pi, doesn't it? But there's no interval here. And since there's no interval here, we need to put these, and these are pi apart, we're just going to put beta equals 0 plus pi n. That would be my answer here. All right.